Let us take a question on halofarm test. Find out the number of compounds that give a positive iodoform test. A very interesting question, very important also. Either in cold or hot condition. Okay, let us check out the things one by one. Then finally, okay, look at this question. I think just looking at structures, you can say the answer to some extent. But you should know what this condition is in cold or hot condition. You know, the basic point what I would like to say is iodoform test is given by or haloform test, whatever, given by compounds with this particular group. In fact, this is what we have taken when we discuss the mechanism. You know, this is called methyl keto. Methyl keto group. Almost half of the options can be checked with this. Even this also is okay. You know, this is methyl carbinol. You know what a carbinol is? Not only these, but the compounds which can give these varieties. Those compounds which can give these group containing compounds. somehow if a particular compound can give compounds with these sort of groups, I mean the methyl keto or methyl carbinol. You know, methyl keto is in fact obtained from methyl carbinol. Just remove these two hydrogens, you get a fresh bond here, isn't it? So that's how methyl, yes, methyl ketones and methyl carbinols are to be checked out. Come on, let us see them. Now say this is a methyl keto group. Now, as per the mechanism, we know that the bond undergoes cleavage at this position, right? This part becomes iodoform because anyway, this is treated with iodine in the presence of alkali, right? So this part becomes iodoform and this part becomes a carboxylate as per the mechanism. So this one is okay. Now coming to the second one, even this also is okay. It has already reacted with iodine and now it is ready to react with alkali. Recall your memory with regard to the mechanism. What has been already discussed. Right. Now, this is where it just goes off. Even this also is okay. Now look at this. So this is a methyl carbinol. Even this also is okay. Now look at this. You know, this also is a methyl carbinol, of course, but already a hydrogen atom is being replaced. I mean, one molecule of iodine has already reacted with the alcohol. So we got this iodine here. It will now react with two more molecules. That is how the reaction goes on. Coming to this ethanol, look at the way it has to be written. CH3, CH, OH, then write a hydrogen here. Now it has come to methyl carbinol kind of structure, right? So even this also will give you our iodoform. Now coming to this one, yes, you can cut it here. This part becomes benzoate and this one gives iodoform. Okay. Next, this is very interesting. This G is interesting. No, it actually has got no methyl ketone, no methyl carbinol, but you know it comes under this category. Check this out. Let us do one thing. Let me just treat it with an alkali, say aqueous alkali, so that this will become okay. OH, another OH, then this is CH. We know that a carbon carrying two hydroxyl groups is highly unstable. It immediately undergoes elimination of water molecule, and you know finally we get something what is needed. You got your methyl keto, right? So even this also is okay. Now this one already there, got methyl keto group. So even this is okay. And even this I is also very interesting. Check this out, guys. G is special, even I is also special. Special because you know it is actually an ester. Of course, it's a course, it is having a methyl keto group, but still, it's neither a carbonyl compound nor an alcohol. But see how it gets converted into compounds with those groups. Ester hydrolysis in the presence of base. You've seen the mechanism. This will become CH3COO minus, isn't it? Then the ethoxide, of course, ethoxide finally takes a hydrogen from, a proton from this and becomes ethyl alcohol. Now, this ethyl alcohol is what is going to give you iodoform, just like E. Okay. So, finally, all 9 can give positive iodoform. Just go for questions on these. Very interesting, very, very important. Just given one question, but of course has very interesting options. Okay. Now let us go for a very important named reaction, a rearrangement. Pinacol, pinacolone rearrangement. Let us just go on taking different examples. To start with, let me take a basic pinacol. See, this of course is a vicinal diol. Okay. Famously known as pinacol. In the presence of an acid. In fact, the first step is actually a very important step, but here it doesn't play any important role because see, both the hydroxyl groups are in the same environment. They are connected to the carbons which are in the same environment, right? So we can take one of these. Okay, then look at what we get. Okay. Now simply remove this water molecule. See, when a water molecule is removed, we get a positive charge. Okay. See, as of now, it is stable, but still, if you want to make it more and more stable, go for rearrangement. Now it has got 2 plus I groups. Of course, the releasing ones, so they can just stabilize the carbocation. But the point is, if suppose I go for this rearrangement, then I mean this 1,2 CH3 minus a shift is going to give us this carbocation, which is stabilized by the plus M of the OH group, right? Plus M. In this case, we have only plus I. Plus M is strongest. Okay. Now, almost done. Now remove this proton and neutralize the positive charge. Finally, we get. Now, this is what I call pinnacolone. So is the name pinnacle, pinnacolone rearrangement. It's of course simple because in the pinnacle we got both the hydroxyl groups attached to the carbons which are in the same environment. But now let us take one more example where it becomes little complex. Look at this. This is when we get confused of which OH group is to be taken into consideration. This is when you need to be cautious. Let me take this one. It is because if this is taken, then we get a positive charge on this carbon, which of course has two phenyl groups, so that the carbocation gets stabilized. Let us just see that. Let me just reduce the number of steps. Let me just remove this as water. We get a positive charge here. Then of course this, and you got OH. Now the point is whether to go for 1,2 hydride shift or to go for 1,2 methyl shift. I mean CH3 minus shift. You know, this is where the migratory aptitude comes into picture. Migratory aptitude can simply be given as of now, it can be given as hydrogen, then aryl, then alkyl. Now we got, this is an experimentally proved one. So let me just take this into consideration. Okay. 1,2 hydride shift is what I've taken. Now anyway, it is stabilized. But still, it is going to get stabilized because of plus M. This is where you get a positive charge backed by the plus M of oxygen. Let me just take it this way straight away. Remove a proton, what you have used in the first step. This, of course, is an acid catalyst. Come on. You get C double bond O, CH. Okay. So whenever there is a kind of confusion of what is to be shifted, then take help of this migratory aptitude. We'll give a little complex one later, but for now, I think for this particular question, for most of the questions, this is enough. Okay.